Okay, so we're getting to one of the more exciting parts of the journey, I guess. We have yet to talk about deployment, which is basically the thing that you do that pretty much screws up all of the assumptions that you had made about the application during the time that you were doing development. So deployment is a great topic, and the challenge we had in covering it for this class is if you were doing software not as a service, deployment is basically wait until the CDs get pressed and put into boxes and taken out to the stores, and then after that, there's sort of a maintenance team that takes care of a lot of responsibility. But in software as a service, there's a lot of overlap between the developers and the operators who actually keep the site running. In fact, there's so much overlap that most modern SaaS companies just call the role DevOps. And there's very few developers who don't get involved in some aspect of operations, and there's very few operations people who are not in some way connected to the development team. So just as with testing and development kind of being merged together in the agile lifecycle, in SaaS, development and operations are a lot closer than they have been traditionally. So we'll talk about some of the practices that are used for SaaS development ops or DevOps. We'll talk about continuous integration or CI, which some of you may have heard of, and continuous deployment, which goes along with it. Upgrades and feature flags. How do you upgrade an application without breaking it and having to bring it down because downtime is bad for software as a service? We'll talk about what availability and responsiveness mean. So obviously these are things you'd want your site to have, but how do you measure them and how do you know if you're doing well? And there are some specific things you can do to improve on those metrics, like relieving pressure on the database using caching, indices, and some other tricks. And of course, the world is full of evil forces, so we have to defend customer data against them. So here's how I characterize development versus deployment. Development is the thing that you do to make sure that you've got an app that you have a design in mind, and you're going to test and build the app according to your design. And your tests are checking to see if the app behaves the way that you intend when you do certain actions to it. Deployment is about testing to make sure your app doesn't do something really bad when it's used the way not it was intended. So when people give it nonsense input, when it's attacked by evil forces, when it's overloaded because you're unexpectedly popular, what are the things that happen in deployment, and how do you guard against those things? What techniques can we bring over from development? So here's the bad news about deployment. The bad news is now you're going to have users. Before, you had no users except yourself and the other people on your team, and users are a terrible thing because your system would be a lot more stable, frankly, if it never had any users. It would actually work correctly most of the time. Also, there are some bugs that even if you're a thorough, conscientious tester, and of course all of you are, some bugs really only appear when you subject the app to duress. So there's not really a way that you can effectively test for them all by yourself. There are some ways in which your production environment is different from your development environment, and that can lead to differences in behavior, whether it's bugs or performance differences. And as I said, the world is full of evil forces who are not necessarily trying to hijack your app. They may not care a whit for your app, but they may be trying to use your app as a delivery mechanism for malware or some other scripting attack that really has nothing to do with, they don't want your data, they just want to use your app as a delivery vehicle. So you have to look out for them. And also the world is full of people who will use your app, despite your awesome documentation and great self-explanatory UI, they will try to use your app in ways that you didn't design. So the good news is that we're living in wonderful times, specifically times with platform as a service offerings like Heroku and EngineYard and others, that compared to when I was doing this kind of work not that many years ago, deployment is way easier than it used to be. So the way you used to have to do it is you would have to get a virtual private server. Today we would say it's in the cloud, but back then there wasn't really a cloud, so you just rent a VPS somewhere. You'd have to install and configure a whole bunch of stuff, roughly the contents of what's on the VMs that we populated for you all for the class. You may or may not have heard of all the programs on this list, but believe me, you cannot stand up even a simple web app without all of these things. Then there's security vulnerabilities. I'll show you some fun examples of those in a moment. But you'd think that security vulnerabilities is something you sort of like, you go through your app, you audit, you take care of them, and now you're done. No. Security vulnerabilities are being discovered all the time, and just staying on top of the vulnerabilities associated with software that you're using out of the box, let alone vulnerabilities in your own code, can be part of a full-time job. And as a result of that, you'll find yourself in what I call library hell. That's when you have to patch a library or upgrade it because of some security problem, but then there's other things that rely on it, so you have to install those, and you find yourself in like these deadlock cycles where you can never get all the libraries back to a stable state. And if you want good performance, you have to tune all those moving parts. So what are some reasonable, non-stupid default settings for MySQL or for Postgres? What if you're using things like caching or memcached? What are some reasonable settings for that? How do you tune it? Again, that's a whole separate chunk of ops. It's got nothing to do with your app, but it takes your time. To give you an example of the kind of fun you can have with security vulnerabilities, and I'm sure I have to fix the video here. This is one of the many thrilling pages of a security vulnerability scan. Again, this is from an app that I've been maintaining for a few years. And initially, when I had it deployed, I kind of did my homework in terms of locking down parts of the app that weren't going to be parts of the system that I thought my app wouldn't need, closing any security holes. And then I ran a required quarterly security scan. Because I accept credit cards, I have to have my app scanned every month for all kinds of vulnerabilities. So this is the first time I did it, I got a 25-page report of the security vulnerabilities. I had 73 vulnerabilities, 16 applications running on my server. Of course, only one of those apps is actually mine. But Apache is an app, the database is an app, the cache is all those things are apps. Some of these vulnerabilities are considered red. A CVSS vulnerability score of 10 means fix this right now or evil people will get your app. And just understanding the names of some of them, OpenSSH, GSS API, remote code execution vulnerability. Like I know what all those words mean individually, but what is this supposed to tell me? So 25 pages, right? It goes on. So most of these vulnerabilities are not even in my app, right? But I have to take care of them because they're part of the overall stack that I use. So how are we going to handle most of these? Well, for the most part, if we stick with platform as a service, and there's actually a good justification for why we can do this, it actually handles a large number of the things that aren't really part of your app, but have to be curated and somebody has to keep an eye on them. So for example, there's horizontal scaling. We know that you can't sort of scale your way out of the database, but you can add capacity at the front end and in the app server. Platform as a service offerings have some automation around that. Previously, you would have had to do that yourself. Component level performance tuning. If you have a MySQL installation, how do you tune that? You don't have to worry about that anymore because PaaS handles most of that as well. And infrastructure level security. So security as it relates to staving off denial of service attacks, port scanning. Again, things that don't have to do necessarily with your app, but that somebody's got to take care of. A lot of those things now are handled for you. And lest you think, well, is my app really going to be too big? Or what size app could you really get away with this approach? All of Pivotal Tracker runs on a single database. So for all practical purposes, you could think of Pivotal Tracker as a managed PaaS kind of application. And you can run it on a box that costs less than $10,000. And also, a lot of apps, including the ones that you might be building for projects in this course, don't necessarily have a global audience, right? We don't all need to be Facebook. If you have an app that several thousand people use, that can be trivially put onto a platform as a service. So let's talk about what are the problems that are largely addressed for us. What does performance and security mean in this context? The most obvious example is availability and uptime, which is roughly what percentage of the time can people use your site. And as we'll see, that's actually trickier to measure than you might expect. Responsiveness, assuming that your site is up, when I click on something or when I take some action, how long does it take for me to perceive a response? Is it milliseconds? Is it seconds? Is it, heaven forbid, tens of seconds? Scalability, and there's many definitions of it, but the one that we're going to use for software as a service is if I get more users, can I maintain the same responsiveness? In other words, everybody continues to get good performance without increasing the cost per user. In an ideal world, maybe even decreasing it. Privacy, is data access limited to the appropriate users? If my users are storing private data, is it really private? Are there kinds of data that are only accessible to site supervisors and so on? So that privacy is kind of one of these cloud of concepts that really encompasses a number of things, but roughly speaking is, do only the people who have authorization get to see certain kinds of data? Authentication, which we've already seen before, is can we trust when a user is interacting with the app that he or she is who they claim to be? And data integrity, which means if somebody tampers with the data, can we at least detect that or maybe even prevent it? So trying to keep our customers' data safe. So some people will call the first 2 or 3 topics in the list performance stability, especially availability and responsiveness, and the rest of them really are about security. We're going to sort of conflate the discussion because there's sort of all of these figure into operations because they're things that you can do some testing when you're in the development phase, but really when the rubber meets the road is when you deploy. So here's an introductory question about these, and this is just sort of a concept question to illustrate why some of these concepts are a little trickier than they might appear. Let's suppose that R is some measure of the availability of rotten potatoes. The simplest measure we can think of is what % of the time it's working. 100% means working all the time. 0% means it's permanently down. H is the availability of Heroku, where rotten potatoes is deployed. C is the connection availability for whatever my internet service is at home, like Comcast. And P is my perception of rotten potatoes availability when I try to use it. And here's the question is, what relationship, if any of these, can you state about being true, can you state as being true among those quantities?